Hello everybody, welcome to A to Z Learning Hub. Today is our 6th class in physics and our topic is error analysis. Now question arises, what do you mean by error? Error means mistake. Suppose I give you a length to measure it. Suppose its actual length is 10 centimeter, but you measure as it 10.3 centimeter. So here there is error because actual length is 10 centimeter, you measure it as 10.3 centimeter. So error means mistake or error is equal to true value minus measured value. In that length, your true length is 10 centimeter, you measured it as 10.3 centimeter. So there is a mistake. The difference is called error. You see, this error may arise from different sources. Error may arise from different sources. Therefore, errors are classified as, errors are classified as, your one is systematic error, second one is random error, and third one is gross error. Generally these are three types of error: systematic error, random error, and gross error. What do you mean by systematic error? These are the errors whose causes are known. It means why you commit the mistake, you know it. And this error can be minimized. Which error? Systematic error. This error can be minimized. You see, again this systematic error, you know its causes are known and it can be minimized. Again these systematic errors are different types. These are different types. First one is you know instrumental error. What is instrumental error? It is due to imperfection design of the instrument. That means the instrument is not made properly or erroneous manufacture. Although it is prepared and there is some error or misuse measuring of instrument. That means anyone who uses this instrument could not measure the given quantity properly. This is the instrumental error. Again you see, this instrumental error, you remember, it is due to imperfection design of the instrument or erroneous manufacture or misuse of a measuring instrument. That means we cannot use the instrument properly. Again you see, these instrumental error may be different types. First you see what? Zero error. What is zero error? It is seen in some measuring instrument like vernier caliper. What do you mean by vernier caliper? Vernier caliper is an instrument to measure length. You know, you measure length by meter scale. But why use vernier caliper? Suppose in meter scale, we measure the minimum length up to millimeter, centimeter, meter, like this. Suppose there is a length which is less than millimeter, 1 millimeter, then you use this vernier scale. In vernier scale or vernier caliper, it is seen in some measuring instrument like vernier caliper. Here there are two scales. One is a main scale, which is a normal scale like meter scale. This is a main scale, and here it is a vernier scale. Just I am doing the rough diagram. If zero of a main scale, coincides with zero of a vernier scale, then there is no error. But in most of the vernier calipers, you see zero of a main scale does not coincide with zero of a vernier scale. This is the zero of a main scale and this is the zero of a vernier scale. If zero of a main scale does not coincide with zero of a vernier scale, then this error arises or a zero error arises. Again you see, if zero of a vernier scale, this smaller one is vernier scale. You read it detail in practical. If zero of a vernier scale, you know zero of a main scale does not coincide with zero of a vernier scale. If zero of a vernier scale is a right, does not coincide means what? It is to the right or it is to the left of a main scale zero. If zero of vernier scale is right to the zero of a main scale like this, right to the zero of a main scale, then you remember this type of a zero error is called positive zero error. That means here you get the measured length greater than true length. In positive zero error, you get the measured length greater than true length. Similarly, if zero of vernier scale is left to the zero of a main scale, then we get negative zero error. If zero of a vernier scale is left to the zero of a main scale, then you say it as negative zero error. In this case, the measured length is less than the true length. You remember, in positive zero error, measured length is greater than the true length, and in negative zero error, your measured length is less than the true length. These are the types of zero error. It is seen in vernier caliper. Vernier caliper is a very sensitive instrument which is used to measure the length less than millimeter, 1 millimeter. And here you know there are two scale, main scale and vernier scale. Here in main scale has also 0, vernier scale has also 0. If 0 of a main scale coincides with 0 of a vernier scale, then there is no error. But in most of the vernier caliper, you see 0 of a main scale does not coincide with the 0 of a vernier scale. In that case, that the error arises and it is called a zero error, because the error arises due to 0. And if 0 of a vernier is right to the 0 of a main scale, then it is called a positive 0 error, and here the measured length is greater than the true length. Similarly, if the 0 of a vernier is left to the 0 of a main scale, then it is called a negative 0 error, and in this case the measured length is less than the true length. So this is the what? Zero error. These are going under instrumental error. Another one is very important, that is your least count error. Least count error. Or we can say permissible error. What do you mean by least count error? First you see what do you mean by least count. The smaller division of a scale, the smaller division of a scale in measuring instrument is called least count. The smaller division of a scale, the smaller division in a scale in measuring instrument is called least count. You see, it is called least count. Suppose you see in your watch, I will ask you, what is your least count? You say it is 1 second. In your meter scale, because smallest measurement is a second, in the meter scale, what is the least count? You say 1 millimeter is the least count. Similarly, so the smaller division in the scale in measuring instrument is called least count. And you see, this least count error or permissible error arises due to this least count. This error is due to the limitations imposed by least count of measuring instrument. You try to understand it. Suppose in a meter scale, for example, in a meter scale, what is your least count? Our least count is 1 millimeter. That means it is the smallest length. If the division in that instrument, if the division is less than 1 millimeter, that is 0.5 millimeter or 0.005 millimeter, then in this case, then the measurement will not accurate, because smallest division is 1 millimeter. If the smallest division is less than 1 millimeter, that is 0.5 millimeter or 0.05 millimeter, then you see, while we measure in that instrument, we cannot get accurate measurement. Here you get the error. So this is called what? Least count error or permissible error. This is going under also your instrumental error. Your third error is constant error. What? Constant error. What do you mean by constant error? The error which affects the each measurement by same amount is called constant error. Suppose you measure a length by certain measuring device. When you measure the length again and again, every time we find there is a certain increase of length from actual length, or every time we find there is certain decrease of length from actual length or true length. This is called constant error. This error which affects each measurement by same amount. Certain, suppose 0.1 millimeter greater or 0.1 millimeter less. This continues again and again in each and every measurement. So the error which affects each measurement by same amount is called constant error, and it is due to, why it appears? It is due to faulty calibration of scale of an instrument. While this constant error arises due to its manufactural defects, faulty calibration of the scale of an instrument. In that instrument, the scale which is fitted is wrongly calibrated. Therefore, this type of error arises again and again. Next come to your fourth, under instrumental error. This is the constant error, and your fourth error is backlash error. You see, it is seen in screw gauge. You know, screw gauge is also another measuring device which is used to measure length. That means here you rotate its scale. When we try to rotate the screw, there is a screw very fast. Suppose you quickly rotate very fast during measurement, there is some slipping of a division. You see, this like this. Suppose you rotate it quickly, then there is some slipping of a division. Instead of one division, there will be two division or a three division like this. This is due to fast rotating. So, and if there is more than one division are slipped, so there must be what? Error. So, to avoid this, the screw gauge must be rotated slowly and in one direction. To avoid this, the screw gauge must be rotated slowly and in one direction. You remember. This backlash error is seen in screw gauge. You will see in your practical class what is screw gauge. Screw gauge is a measuring instrument which is used to measure the length. when we use if you don't properly use the screw gauge, that means we try to rotate the screw gauge very fast. Then during the measurement there is slipping of some division. Instead of one division there will be 2 or 3 division at a time. In this case we find error. And this type of error is called a backlash error. And to avoid this, the screw gauge must be rotated slowly. That means one by one division will come and in one direction. You don't rotate in two directions. Slowly and in one direction, so that this error can be eliminated. So these are the errors. Instrumental error, first one is your zero error, I say, then is your least count error, next is your constant error, and fourth is your backlash error. These are the systematic error. First part, this is the instrumental error, and instrumental error has 4 different errors. Next systematic error is known as personal error. What? Personal error. It is due to imperfection of the observer. What is imperfection of the observer? Suppose you give a length to someone, you measure its length by vernier caliper. Suppose that person don't know what is vernier caliper, how you measure it, then that means he is not perfect in that instrument. When you measure that length in that instrument, he must commit error. So that error is known as a personal error. That means error by man, by person. It is due to imperfection of the observer. That means that observer which measures that instrument, measure the quantity by the instrument, is not well acquainted with that instrument. Next come to your imperfection. Third one is imperfection in experimental technique. Imperfection in experimental technique. What is that? That means here some facts are ignored. Facts are ignored. What is some facts are ignored? Suppose you measure the time period of a simple pendulum. Simple pendulum is like this. Suppose you measure the time period. When we measure the time period in air, when we swing the time period, that bob of the simple pendulum in air, there must be air resistance. Air also opposite. But by ignoring the air resistance, we measure the time period. This is the imperfection of the experimental technique. We ignore the air resistance and we measure it. This is called imperfection in experimental technique. Another one is, fourth one is by external factor. External factors. When we measure the instrument, when we do an experiment, there is some external factors like temperature, pressure, humidity play the role. So they also affect the experiments. So while we do experiment, while we do measurement, we must consider about that temperature, pressure, humidity like this. This external factor also affects the measurement of certain materials. So you see, so your systematic error, first one is your instrumental error, second one is your personal error, it is due to a person, third one is imperfection of experimental technique by ignoring certain facts, and here there is external factors like temperature, pressure, humidity, like this. This is your systematic error, and this error can be minimized or eradicated. Another one is your second error is random error. What do you mean by random error? Random means haphazard. This error which occur irregularly and at a random in magnitude and direction. This error occurs irregularly and at a random in magnitude and direction. That means you cannot know from which direction and by how many magnitude the error occurs. You cannot know the exact cause from which direction this error take place. And you see, the cause is not the cause of the error is not exactly known, and it is not possible to remove them. We cannot remove this error because we don't know what is the cause, from which direction and by what magnitude the error is coming, so it is not possible to remove them. It has no a particular cause, it has several causes. It has several causes. So many causes are there. Suppose I say a person repeats a measurement. Suppose a certain length is given to a person, you measure the length by certain instrument. You see, the person measures the length again and again, and in each time he gets different length. Suppose in first measurement A1, A2, AN. N times measure and he got A1, A2, N. This is due to, you see, why this is happening, why the different lengths are coming, that person cannot know and no one cannot know. So, in this case, if there is a random error, to find true reading, what we have to do? We have to take the average of all the length, mean of all the lengths. That is your A mean is equal to what? A1 plus A2 plus AN divided by N. You remember, if there is a random error, you don't know what is the exact cause. At that time, you measure it several times and you take the mean of all this measurement and you get the true length. Next, another one is your third error, that is your gross error. This gross error is called what? Mistake, you say. At first, I was telling you, error means mistake. This gross error is called a mistake. What is gross error? You remember, it is due to carelessness of the observer. The observer is efficient, but this gross error or a mistake occurs due to carelessness of the this error, gross error you say it is a mistake, and this error is due to carelessness of the observer. What do you mean by carelessness of the observer? Suppose I give you a length to measure it by measuring instrument. While you measure it, suppose there is a phone. Hello? You engage in that phone call, but you don't care the measurement. In that case, there must be mistake, and this is called gross error. This is due to carelessness of the observer. Under this carelessness of the observer, you see, first one is your reading the instrument without setting it properly. Without setting it properly. This is the first type, gross error. Second one is unknowingly taking the observation wrongly. Taking observation wrongly. Third one is writing observation wrongly. And fourth one is reading the observation wrongly. These are the gross error. All are due to carelessness of the observer. So, you see in error analysis, theoretically I say there are three types of error. One is your instrumental error, second one is your random error, third one is your gross error, which is known as a mistake. Again you see this instrumental error may be different types. First one is your systematic error, then is your random error and your gross error. Your systematic error may be instrumental error. Under instrumental error you get zero error, least count error, constant error, backlash error, and then there is another systematic error which is known as a personal error, and the third one is your due to some external factors, and fourth one is your imperfection of the experimental technique. That means by you omit certain facts, we ignore certain facts. In this case we find these are the systematic error, and these error can be eliminated. Your second error is a random error. You don't know what is the magnitude and what is the direction of the error and what are the actual causes of the error, and this error cannot be minimized. And you remember one thing, in order to get if there is a random error, you take the measurement again and again, and you take the mean of this all measurement, arithmetic mean of all measurement, will get your random error. Third one is your gross error. You remember what do you mean by gross error? Gross error means carelessness of the observers. What is the carelessness of the observer? That is the reading of the instrument without setting it properly, taking the observation wrongly, writing the observation wrongly, and reading the observation also wrongly. These are the qualitative factors, qualitative aspect of error analysis. Next come to your quantitative aspects of the error analysis. Your first one is your absolute error. Absolute error. Second one is your relative error, and third one is your percentage error. These are the qualitative analysis. So, for today, I read the I teach you the error analysis in qualitative way. If you like my teaching, please subscribe my channel so that I will be motivated to give you better and better video. Today, thank you everybody.